This is problem number 5 on the practice problems for test number 1. 1 year after being purchased, a piece of machinery in a factory has an assessed value of $13,200. After 4 years, the value of the machinery is assessed at $7,800. Let V represent the value of the machinery in dollars and T represent the number of years since it was purchased. A. Express V in terms of T, assuming that they are related by a linear equation. So first thing I need to do is try to get back to basics. I'm looking for an mx plus b thing, but I've got unfamiliar letters here. I've got a v and I've got a t, and I got to figure out which one is which. I've got v and t, and in some order, they're x and y. Maybe it's that order, maybe it's the other order. So the only hint that we give you in this problem is this phrase right here, v in terms of t. And there's a phrase that I've got memorized, and the phrase that I've memorized is y in terms of x. Y in terms of x. That is the normal order that x and y are written. And what that means is that y is equal to something something with x's in it. And so in this problem, it says v in terms of t. So we want v to equal something something with t's in it. What that also means then is that the v in our problem is like the y, and the t in our problem is like the x. So then instead of having our normal x comma y points, our points are going to be of the form t comma v. So we've done a lot of translating, but I think it's worth our time to get to that point, understanding what is like x and what is like y. So let's go ahead and see if we can fill in some points here of the form t comma v. And we're going to try to read information off of the problem. So the problem first says that a piece of machinery has an assessed value of $13,200 1 year in. So where do you put the 1 and where do you put the 13,200? Well, 1 year in is time, that goes first. V is value, 13,200 goes there, it's like the y. And then the other numbers here, 4 years in, $7,800. So 4 is the t, it goes first. 7,800 is the value, it goes second. And now that we've got the 2 points, now it looks like x comma y, it's very familiar to us. We could ignore the problem, the paragraph and the money and the time, but just solve like a normal y equals mx plus b thing. So the first thing we'll do is find our slope, change in y over change in x. I'm quite happy to just go ahead and subtract the y's, although technically they're not y's in this problem, they're v's. X's are t's. But we've got them looking like x's and y's, so we just subtract 13,200 minus 7,800 over, just be really careful, you subtract in the same order. I did 13,200 minus 7,800. I must do 1 minus 4 downstairs. Okay, we subtract these numbers here. That's a 5,400 up on top, negative 3 on the bottom. And it happens that that goes in evenly. That's equal to negative 1,800. Okay, so we've got our slope. Next thing to do is to find the b. So again, we'll go back to our normal equation, y equals mx plus b. And we'll start substituting in. So instead of y, we're going to put the y coordinate at one of these 2 points. Makes no difference whether you select blue or purple. I'll select blue. The number 1 is going to be easier to plug in than 4, but it makes no difference. So how much is the y coordinate for that blue point? It's 13,200. How much is m? That's the slope. We just found it is negative 1,800. How much is the x coordinate? Again, at the blue point, that's 1. How much is the b? We don't know, but that's what we're about to find out. So this says 13,200 is equal to 1,800 times 1 is just 1,800. So negative 1,800 plus b. Add 1,800 to both sides, and we get b is 15,000. So that means that the final equation we have, y equals mx plus b, this one here. Instead of m, we figured out it was negative 1,800. X is now just x plus b. B is 15,000. Part B, what is the slope of your linear equation from A? What does it mean in the context of this problem? So because we did all that work to get something that looks like y equals mx plus b, we can just grab the slope from our equation. Although that's actually kind of silly because we did all that work to just find that the slope was negative 1800, so scratch that. The slope is just negative 1800. That's what we found up there in black. So negative 1800 was our slope, just copying it down over here. And then what does it mean in the context of the problem? Well, I always like writing units to help me figure out the context. So what were the units here for our slope? Well, we had change in V over change in T. What were the units for V? That was value, that was dollars. How about T? Well, T was measuring time, which was in years. So then the units for the slope are just the ratio of those two things, dollars per year. So this is negative $1,800 per year. Or maybe written in a more standard looking way, negative $1,800 per year. So what's the interpretation? The interpretation is that the value changed by negative $1,800 every year. Or if you want to change the negative sign to decreased, then we could say something like the assessed value decreased at $1,800 per year. Your sentence doesn't have to be word for word with that, but it does have to get all the ideas across. And maybe instead of at, I'll change it to by. Assessed value decreased by $1,800 per year. Part C, when will the machinery be worth $2,400? So we're going to copy that purple equation. And definitely we're going to substitute something for 2,400, or 2,400 for something. So you know what, I probably shouldn't have written that purple equation with x's and y's. Let's change that. Instead of x's and y's, let's go to the letters that were actually given in this problem. It was v's and t's. So instead of y, we decided that y was, over here you can see the substitution, y was the same as v. So we're going to replace the y with the v. That's this one. And then we'll change the x. This x goes away. And you can see over here, x was really t. So this is negative 1,800 t. Okay, so then I'll make those same replacements down in the bottom. I think using the right letters, well, number one, that's what the problem said to do. So technically I had the wrong answer with x's and y's. But using the right letters is going to help us understand what to do with this 2,400. So when will the machinery be worth $2,400? Well, is 2,400 the V or the T? Is it a value or is it a time? Clearly it's a value, so we just substitute. Instead of V, we put 2,400. Everything else gets copied. The goal here is to solve for T, so we'll first subtract 15,000 from both sides. So that gives me 12,600 over here. Divide both sides by, I made a mistake, that should be negative. Divide both sides by negative 1,800. And whatever I get is T. Use the calculator to help us here. 12,600 divide by 1,800. Notice I didn't type in the negative signs. In my mind, I've just canceled them, so less to type, less chance to make a mistake on the calculator. And we just get 7. So T is equal to 7. 7 what? T was measuring time in years. So after 7 years, the machine will be worth $2,400.